Hi, welcome to another video of mathforallgrades.com. This video will teach you an important concept in the topic of time and work, and the concept is called one day work. Let us start with an example. Consider this. A person A takes 3 days to complete a work working alone. Another person B takes 4 days for finishing the same amount of work working alone. If A and B work together, then how many days will they take together for finishing the same amount of work as done by each of AB in their respective times? If you observe, you cannot add these two numbers 3 and 4 straight away and give the answer as 7. It would be illogical. It is expected that it is easy to see that the number of days taken together by A and B to finish an amount of work which is done by both A and B, the same amount of work. It is easy to see that the number of days taken by A and B for finishing together a work which is done by A in 3 days and B in 4 days cannot be more than either 3 or 4, because the amount of work being done is assumed to be same. Whatever amount of work is done by A and B individually is also the same amount of work given for them for finishing them together. So together A and B cannot take 3 plus 4 7 days to finish an amount of work which is same and which is done by A in 3 days and B in 4 days. We should expect A and B to finish the same volume of work in a time which is less than both 3 and 4. So in this case, direct addition does not make sense. Direct addition of numbers will make sense for quantities which are related by direct ratio or proportion. For example, if a book X costs 30 rupees, another book Y costs 40 rupees, then the total price of the two books X and Y would be 70 rupees. In this example, direct addition is sensible and practical, logical, because more the number of books purchased, more will be the price incurred. So direct addition for these quantities makes sense. Quantities here are number of objects to be purchased and their price. Between number of objects purchased and price incurred on them, there is a direct relation. Greater the number of objects to be purchased, greater will be the expenditure. Similarly, less in expenditure can enable you to buy only a fewer number of books. So a direct relation is there. Increase in number of books to be purchased will incur an increase in the expenditure. If you spend less amount of time, then you can only purchase less amount of books. Increase here will induce increase in the other quantity. Decrease in price will bring about a decrease in number. So there is a directness in the relationship between number of objects to be bought and the price incurred on them. But between number of people trying to finish a same amount of work and time, there is inverse relation. You can expect this. Whatever time you and your friend take to finish a work working alone will be more, the time will be more than what you will take in finishing the same work when you and your friend work together. So there is an inverse relationship between number of people finishing a same amount of work compared to the time taken. So number and time are inversely related. More people will take less time, and if you give more time to finish the same piece of work, then less people can be employed to finish the same volume of work. So between number and time for finishing a same amount of work, the relationship is one of inverse. So now, what is the alternative to solve this question? What we do is find out how much amount of work is done by each person in one day. So let me calculate the amount of work done by each person in one day. The amount of work done in one day by A will be 1 by 3. How is that? I will tell you. A will be assumed to be finishing a same amount of work every day. So, if A is taking 3 days, if a person A is taking 3 days to finish an amount of work, then it will be assumed in this topic that every day A will be finishing a same amount of work. If you do not assume A as finishing a same amount of work every day, which is of course theoretical, may not be practical, then we can never solve these kind of questions. So the assumption is imperative in this topic. So assume that A will finish 1/3 of the work on the first day, another 1/3 of the work on the second day, and a last piece of 1/3 remaining on the third day. In this way, in the first, second, third, that is in 3 days, A will be doing how much amount of the work? If you add 1 by 3 3 times, you will get number 1. So A will be finishing the given work in 3 days by finishing an equal fraction of the work every day. Now how come when the sum is 1 we are saying the work is getting finished? You must note that in this topic, number 1 represents the full amount of work given, or also imagined as completion of the work. Just think for a while. If fraction 1 by 3 represents a part of the work finished in one day, then what is the number that will represent the total amount of work given? Or what is that number which will represent completion of the given work? It should of course be 1. For example, if you say, I have finished 50% of the work, then you mean to say half of the work is done. You must note that 50% is 1 by 2. These conversion of percentages into fractions we have dealt in detail in our videos on percentages. You can watch them if you have not seen them. And if you say 100% of the work is over, you mean to say, you imply that the given work has been finished. Now what is 100% equal to? 100 into the fraction 1 by 100, which is 1. Therefore, you must note that number 1 in this topic represents the work given, or the total work, the full work, or completion of the work. Therefore, if A finishes, means A will be doing one work. The work which is given represents 1. So in this way, A takes 3 days to finish the work represented by 1, and by doing 1/3 of the work every day. Similarly, B also will be finishing 1/4 of the work every day. Here again, you will have to assume that B will be finishing every day 1/4 of the work, because B is taking 4 days for finishing the work. Finishes the work means what number ought to be written in the right side? You guessed it right. It is, of course, 1. In this way, B will be finishing every day 1/4 of the work. So, together, A and B will be finishing what fraction of the work every day, what part of the work every day. Together, A and B will be finishing this sum, that's the part of the work every day, which is 7/12. I will simplify it for you. You have to find the LCM of 3 and 4. LCM of 3 and 4 is 12. That is their product, because 3 and 4 do not have any common factor. So 12 is the LCM. So 4 into 3, 12. 3 into 4, 12, and 4 into 3, 12. This is equal to 7/12. In this way, every day A and B are finishing 7/12th part of the work. Let us assume they will take in this way n days to finish the work. Finish the work means what number you will write? Of course, 1. So n is the number of days. For each day, A and B will be finishing 7/12 part of the work. For n days, they will be working at this rate every day. So, in n days, by finishing at the rate of 7/12 every day, the work gets finished by them, means 1. So, number of days taken n will be equal to 12/7. This is how you will have to find in this method the number of days taken by 2 or 3 persons working together when their individual time rates are given to us. Here you can remember a shorter way. If you observe, 12 is the product 3 into 4, while 7 is the sum 3 plus 4. 3 is the time taken by A for finishing the work alone. Similarly, 4 is the number of days taken by B. So, product by sum can be remembered as a formula, as a shortcut for finding the total number of days, the number of days taken by the two people working together. But this explanation deals with the important concept of one-day work in this topic, because all this explanation, all this concept, the method has arisen due to the basic principle that number of days, between number of days and number of people, the relationship is inverse and not direct. That is why 1 day work, 1 hour work, 1 year work, or work done by the people in 1 day is always gone after for finding the amount of time taken by several people working together, of course, to finish a same volume of work. Hope you found this video useful. Thank you.